Hello students, welcome back from vacations. Today I will start chapter 9 because you already have read the theory of this chapter. So I will start from problem 9.4. So this is very simple problem. Why I chose this problem? Because the next few problems are based on problem 9.4, such as problem 9.5 or 9.6, especially problem 9.6 is based on problem 9.4. So this problem can help you to solve the other problems. The statement of the problem is that a uniform block of mass m and dimensions a by 2a by 3a spins about a long diagonal with angular velocity omega. Using a coordinate system with origin at the center of the block, we have to find the kinetic energy, which is the first part, and then we have to find the angle between the angular velocity vector and the angular momentum vector about the origin. So as it is mentioned in the statement, this is the rectangular block of mass m and it has dimensions, different dimensions a by 2a by 3a, and it spins along diagonal with angular velocity omega. So you can refer to this diagram. So here you can see this rectangular block, it spins along this diagonal and its angular velocity is omega. So here you can see this is symmetric case, both sides along the diagonal, both like this side and this side, both are symmetric, and also it is a rectangular. So in this case the coordinate axes are principal axis. Maybe you read about chapter 8, there is a table I included here, the table 8.3.1. this table tells it tells you about the value of k square depending on the body dimensions and body what we say its shape. So in our case you can see this rectangle, like this this is the red border, and here we will use the value of k square, which is a square plus b square divided by 12, because our case is also a rectangular case and its dimensions are different than the dimension which are mentioned here, but still we can use these values. So we have to find the moment of inertia like I1, I2, I3, and here first we to find the moment of inertia I1, it is equal to m into 2a square. 2a square means this is the one dimension 2a and this is the so this is the second dimension 2a and this is the third dimension 3a. So because moment of inertia is I1, so in this case it should be equal to m into 2a square whole square plus 3a whole square divided by 12. So we can say this is b square plus, based on the formula which is mentioned in table 8.3.1, and this is c square in other words. So its simplified value is 13 divided by 12 ma square. So this is the value for I1. Similarly, the value of I2 is equal to m into a square plus 3a whole square divided by 12, and its simplified value is 10 divided by 12 ma square. And I3, its simplified value is 5 divided by 12 ma square. So now we have the values for moment of inertia I1, I2 and I3. for omega vector, we know that this is the vector, and when we use this is very basic formula. So and the above term here, it is omega, and divided by this is omega, what we say, determinant of omega. So you know how to calculate the determinant. We take the square of coefficient of each term. Like here we took the square of 1, we took the square of 2, we took the square of 3 here in the denominator to calculate the determinant. So its simplified value is that omega divided by square root of 14 into e1 unit vector plus 2e2 unit vector plus 3e3 unit vector. So this is omega 1, omega 2, omega 3. So the first part of the problem is that we have to calculate the kinetic energy. So in order to calculate the kinetic energy T, we can use equation 9.2.5. You can see this equation in your chapter of analytical mechanics. So this is the equation 9.2.5. Here I labeled it as equation 1, and the equation is that the kinetic energy is equal to 1 divided by 2 into I1 omega 1 square plus I2 omega 2 square plus I3 omega 3 square. So we already have the values for I1, I2 and I3, and we also have the values for omega 1, omega 2 and omega 3, which is omega 1 is omega divided by square root of 14 e unit vector, omega 2 is omega divided by square root of 14 into 2e2 unit vector, and omega 3, it is equal to omega divided by square root of 14 3e3 unit vector. So now we have to plug these values into equation 1, the value of I1, I2, I3 and the values of omega 1, omega 2 and omega 3. We have to plug these values in equation 1 in this equation. So here the simple there is a simple mathematics. So we have to do just simplification. So after putting the values, the kinetic energy, it is equal to, the kinetic energy is equal to 7 divided by 24 ma square omega square. So these are the values. You can do practice by yourself, and like this is the value of I1, this is value of omega 1, similarly this is value of I2, this is value of omega 2, and this is the value of I3, and this is the value of omega 3. So we just simplified it and we got our results, which is kinetic energy is equal to 7 divided by 24 ma square omega square. The second part of the problem is that we have to find the angle between the angular velocity vector and the angular momentum vector about the origin. So before finding the angle between angular velocity vector and the angular momentum vector, we have to find angular momentum first by using equation 9.2.4. So this is the equation 9.2.4. I labeled this equation as equation 2 in this problem. So equation is that angular momentum is equal to E1 I1 omega 1 plus E2 I2 omega 2 plus E3 I3 omega 3. So again we have to plug the values of I1, I2, I3 and omega 1, omega 2 and omega 3 into equation 2 to find the angular momentum. So after plugging the values, you can see here like this angular momentum, it is equal to 13 divided by 12 ma square, which is the value of I1 dot omega divided by square root of 14. This is value of omega 1 into E1 unit vector. Similarly, plus 10 divided by 12 ma square, which is the value of I2. This is multiply actually 2 omega divided by square root of 14. This is the value of omega 2, and into E2 unit vector, plus 5 divided by 12 ma square. This is the value of I3, and which is multiplied with 3 omega divided by square root of 14, and this is E3 unit vector. I think it is not prominent, so let me write it again. So this is E3 unit vector. So after simplification we can have L, which is angular momentum, which is equal to 1 divided by 12 into square root of 14 into 13 E1 unit vector plus 20 E2 unit vector plus 15 E3 unit vector ma square omega. So in this case this is not omega square, this is omega. So we know that here we have to calculate the angle. So in order to calculate the angle, we know that cos theta, it is equal to omega dot L. This is the angular frequency dot angular momentum divided by determinant of omega and determinant of angular momentum L. So here we need to plug the values, the relevant values in this equation. After plugging the values, we can have like the value of here the value of I1 is 13 divided by and omega 1 is 1 divided by 14. So here I just plug the values here, and after that I simplify. This is determinant, you know that, like the determinant of omega, and this is the determinant of angular momentum. And when you take the square root of 13, square root of 20 and square root of 15, like here, this is actually square root of 13. The coefficient of first term, we take square root, we take square of coefficient of first term, and then square of coefficient of second term here. Similarly, square of coefficient of third term of angular momentum. So when you solve this square, you will get 794, square root of 794. So here we simplified it. After simplification we get 98 divided by square root of 11, 6, and its square root is 105.43. So cos theta is equal to 0.92953. So in order to find the value of angle, value of theta, we have to take cos inverse on the right hand side. So when you have to do this on your calculator. When you will do this, you will get 21.64 degree. Okay, so it's not radian, so in degree its value is 21.64. so this is the angle which they demanded in part B. So this is all about problem 9.4. so I believe you will solve problem 9.5 and 9.6, and if there is any problem you can discuss with me. So I will choose I will choose the other problems from this chapter. Okay, thank you.